Okay, so from our logarithmic quiz, logarithmic and exponential expressions and functions, the most commonly missed questions, is this true or false? So what I would do is probably take the first one because it doesn't have the word log in it. So this guy, and I would convert it to logarithmic or take the log and convert it backwards. So log, this is our exponential base. So log base 10. So there is no base, so that's perfect. So log base 10 of 2x minus 1 is equal to exponent x plus 4. So equal to exponent, as I remember explaining, like those two e's is kind of a little helpful maybe to memorize what comes after the equals. So in this case, this is true. This exponential does turn into this logarithmic form. When there's nothing in the basement, remember that's a log base 10, kind of like 1x when they don't write the 1, same idea. So exponential, so we're now going from log to exponential. So base of 2x minus 3 is 3. So log base x of 3. So take our base, grab our exponent, come out with an output. So again, this one is also true. The exponential form of log base x of 3 is 2x minus 3, and its exponential form is x raised to 2x minus 3 equals 3. All right, so both of those should have been true. Solve for x, round to the nearest thousandth. Now, 100%, we're in Math 3. If you do not round to the nearest thousandths, I will not give you credit because it's a matter of you have to follow directions. We have an EOC, and you have to be able to do what it tells you to do. Within a copy, they do not give you partial credit, so that is definitely a must. We need our base by itself so we can switch it to logarithmic form. And the reason you're switching it to logarithmic form is because that x is in the exponent spot. A backup plan, which I will show you after we solve it. Actually, let's do this. So we need to move the 1 to get that 8 to the 3x by itself. So now I have 8 raised to the 3x. That 1 is over here with that positive 43, so it's equal to 42. And now it is in its simplest exponential form. So we can switch it by pushing the base down into the basement. So log base 8 down in the subscript of 42 is equal to exponent. So now we can solve this because log base 8 of 42, you can plug in to Desmos, losing my words, sorry. So we're going to do log, base 8 of 42 is going to give us that decimal. And then we're going to divide that number by 3 because that 3 is attached to the x as multiplication. So we could also save ourselves some time and divide by 3. So our answer should be 5. It's a thousandth place, so just 3. So tenths, hundredths, thousandths. So it should be 0.599 as our answer. Now, backup plan EOC. So ultimately, you need to be able to convert them, and you need to be able to answer the question. And it's 0.599. But if that is a problem, now granted, 0.599 is going to be really tough to find on your graph because that's not a whole number. But hey, sometimes we forget everything, and we really just need to get close to the right answer. Maybe it's a multiple choice, any of those fun things. So there's my log, and the problem said 8 to the 3x plus 1 is equal to, so we're going to make this one function, so we'll call it f of x. Or you could put y. I like to do f of x because we're about to put another function in, which we'll call g of x, and that's the output, which in this case was 43. And we are going to look for where they intersect. So 43 is going to be way up here. .599. So when when y is 43, so that horizontal line, the x value is 0.599, which is the answer we just solved by converting and dividing. So again, this is the left side of the problem. This is the right side of the problem. They're two functions. This is a math 1 skill you did when you had systems, and you're looking for the intersection, and it has to be perfect. Okay? And then that x value would be your answer because you are theoretically solving for x. So again, we put the first half in our first line, the second half in our second line, and we got that 0.59 as the intersection when y was 43. Now, again, math teacher, we're going to try to convert this first, and then we'll go try to check it in Desmos as well. Doing the math is great. Checking in Desmos to make sure we got it right is even better. So we need the simplest form, so log base of equals a number. Anything on the outside is in the way. So we're going to add that 2, and that's going to leave me with log base 6 of x, equals a negative 3 plus 2, which is going to be negative 1. X is with the log, which is a problem, so we're going to convert it to exponential. So when the x is on the side of the log, we can't get a number, so we're going to switch it to exponential. So we're going to take our base, raise it to an exponent, and come out with an output. So 6 raised to a negative 1 equals x. You always have a calculator, but hopefully you remember negative exponents pushes the number into the basement, or it pushes it across. So if it was, and remember all numbers have an imaginary 1 underneath it, if it happened to have been a negative 2/3, or I'm sorry, 2/3 raised to the negative 1, it would just flip. Everything, that 2 would go down to the bottom. So because it's in the numerator, it would now go to the denominator. Had the negative 1 been in the denominator in some other rate, the denominator would come up to the numerator. In Math 1, I teach you to raise the roof and drop it like it's hot, because it's just funny, the idea that a teacher would be raising the roof or dropping it like it's hot. Your attitude would change. Therefore, your exponent becomes positive. So in this case, it should be 1/6 equals x. And it does say, again, round to the nearest thousandths. 1/6. I'm not even sure what that decimal is. Give me 1 second. We'll look it on the calculator. And it is 1.1667 is what we're going to look for, because you want to round. That we're rounding the third place. The next one is a 6, so 5 or greater rounds up to the front. Again, we can go check this in Desmos. So you're going to put the entire left side in line 1, and then your output in line 2. So that would be negative 2. We're going to do y equals negative 2 plus log base 6 of x. And then y equals negative 3. And again, you can do f of x, you can do g of x, you can do functions. It just depends on what makes it make sense to you. So we have our log function here. We have our output here, and the intersection is 0.167. Boom. So solving is important, but you have backup plans. Desmos is life. Okay, so our next one, list all the transformations. This is a little hard to read on my copy. 3 raised to the x minus 5. Now, remember, this is whatever the base. So our parent function would be y equals 3 to the x power. That would be the most simplistic version of this exponential equation. If we were to move it right or left, remember it's x minus h. This controls our right, left. And then plus k controls our up, down. So those of you who got this right, killed it. Those of you who didn't get it right, left it blank, which means I think you have no idea, and it is really that simple. There's nothing in the parentheses with the x, so it did not go left or right. There is only a k value, so this parent function or exponential function of 3x only went down 5. It only went down 5. And I guess some of that has to do with remembering or noting that the parent exponential function is just this guy, the 3 to the x power. And then being attached to the x in the exponent spot, again, is your right, left. Whole number on line with the 3x. Minus 5 would be down. If it was a plus 5, it would be up. Transformations for the logarithmic. Again, x is the left and right axis on your graph. So log base 3 of x minus 2. This is whether it's sliding right or left. Remember, it's an x minus h. So we put a positive 2 in there because it's still an x minus. So that means it's going to go 2 to the right. And that's going to be plus k. So that's going to go up 3. The parent function for this guy, like if you wanted to put it in Desmos and then put in the new one, is log base 3 of x. That is a parent function. Log base 3 of x, log base 10 of x. Whatever this is stays the same, and then it's just x, and then we move it right, left, up, down, depending on the h and the k value. All right, this one was interesting. Again, you guys either nailed this one or did not. In 1996, there's 85 squirrels in Reservoir Park. Now, this is just a basic growth or decay. So we're going to take our starting amount, 1 plus or minus, depending on if it's growth, it's plus. If it's decay, it's minus. Our rate as a decimal raised to the amount of time we're tracking it. And then that's going to equal our population or whatever we're counting. So 85 squirrels is going to be our A, because that's how many we started with. We're going to do 1. The population increase, that's going to be a plus. That 12%, if we divide it by 100 or move the decimal over 2 to the left, we're going to have 0.12. Our T we don't know, but we want to know how long it will take to have 425 squirrels. Now, this is going to be written as such. You can leave T or you can put an X if you like, equals 425. Again, just like solving our previous one, this one may not be as much fun to find in Desmos because the horizontal line at 425 is going to take you a long time to get up there. But you could put the left side in line 1, right side in line 2, and then go find their intersection, because that would be your X. Or we're going to divide by 85 because we need to have an exponent base to a power by itself. I'm going to leave this just as this because we have a calculator. So that means I'm going to get rid of the 85s on this side, and I'm going to work to the left because that's where I have more space. So 1.12 raised to the x is equal to 425 divided by 85. Now our problem is that the x is in the exponent, so we're going to turn this into a logarithmic. Put the base in the basement, so log base 1.12 of, and this is in line with the word log, is x. And then you're going to go put this nasty, ugly bad boy in your calculator and get an answer. So we go to Desmos again. It's going to be log 1.12. And then our fraction, so you want to make sure you put it in parentheses so it does the order of operations right. 425 divided by 85. And otherwise, you're going to turn that into a decimal, and you're going to hope that you round the way they want it rounded. And our answer is 14.2. So it's not in 14 years, because it says in how many years will it be 425 squirrels. At 14, there would be less than 425 squirrels. And at 15, there would be a heck ton more. So lots more. Your other idea at this point is you could have gone from the beginning one. Another way to get around this, and this is how you would have done it in Math 1. And we got to give this a y equals. Sorry, so we can get a table. Y equals, so this is our graph. You could again go all the way up. Like I said, y equals 425. You can scan if you want. I would go over here and change my y-axis, I don't know, 450. We don't really care about any of this, so we can call this 400 if we want, so we can get in there really close. Oh, and I made that bad. It was way better. There we go. So our intersection, $425, it says 35. Ooh. Okay, I have an 8. I was like, man, that's not right. That's not right at all. 85. Now, 14.2. 14.2, so it would be, the correct answer would be more than 14 years, less than 15 years, between 14 and 15 years, and things of that nature. All right, last but not least, one more question. And I think this one people messed up because there's a keyword in there, and there's an EOC release question that says this as well. So 5,000 is compounded quarterly. So quarterly is going to be 4 times a year. So this is the one where we're going to do 5,000. 1 plus or minus our rate as a decimal divided by the amount of time, or n in this case, and then time times n equals whatever we're going for, right? So in this case, we had 5,000. That 0.055 divided by 4. It is going to compound quarterly and grow. And then our time is 12 years times 4. And then we can plug that in our calculator. It's a hot mess, but nonetheless, or in Desmos. So 1 plus, I'm going to double parentheses because I'm always worried I don't speak calculator very well. And I already messed up because we didn't put the 5,000 in. Oh, 5,000. Because you have to have our amount we start with. 1 plus double parentheses to make sure we have our fraction. And I'm speaking calculator the way I want it to be spoken to the 48th, because 12 times 4 is 48. It says 9,630.56, and I'll go 2 decimals because we're talking money. Now, that was one of your answer choices, and it was the most popular missed answer, so that means you did the hard part right. But what is the total profit? So that is not the total profit. That is the amount that's in the account at the point we're checking it. But we put in 5,000, so we subtract that 5,000, and our answer would be approximately 4,630 with some change. So the profit. So making sure you're reading all the words all the way through to the end. I'm a big fan of reading the question, like the end of the question, before I read the entire question. So then I know what I'm looking for. So read the end of the problem, then go back, read the whole problem, maybe read the end of it again, and then knock it out of the park. Because again, you guys did pick what I would call the trick answer, because it is the mathematical answer. It just didn't answer the question that they asked. All right, good luck, guys. Holler if you need me or have any more questions.